Hello, dear students. Now, after moving on to after seeing what is design in a software, we shall now see regarding the details of how actually a design in a software could be like. Okay, so let us start with design in software engineering. Now, once software requirements have been analyzed and modeled, software design is the last software engineering action within the activity that are taking place in design, and it sets the stage for construction, that is for coding and for testing. Now, the requirements model manifested by the scenarios, the class based, the object oriented, the behavioral elements feed the design task. Now, you can see in the diagram that you first have the data class design. Now, what is a data or class design? It transforms the class models into design class realizations and requisite data structures required to implement the software. Okay, so the objects and relationships defined in the CRC diagram and the detailed data content described by the class attributes and other notation provide the basis for data design action. Now, the part of the class design may occur in conjunction with the design of software architecture. The next you can see in the pyramid is the architectural design. It defines the relationship between major structural elements of the software, the architectural styles and design patterns which can be used to achieve those requirements, and the constraints that affect the way in which the architecture can be implemented. The third you can see is the interface design. It describes how the software communicates with the system that interoperates with it and with the humans who are going to use it. The interface implies a flow of information in form of data or control and a specific type of behavior exhibited by the system. The usage scenarios and behavioral models provide much of the information required for interface design. The last you can see is the component level design transformation, which transforms the structural elements of the software architecture into a procedural description of software components. The information obtained from the class-based models, flow-based models, and behavioral-based models serve as basis for the component design. By concluding with this, we shall now move on to what are the design process. Now, the design process is nothing but, you can say, the blueprint which depicts the holistic view of software. Now, what do you mean by holistic? Holistic is a design that is represented at a high level of abstraction, a level that can be directly traced to the specific system objective and more detailed requirements like data, functional, and behavioral requirements. As design interactions occur, these interactions are done in form of iterations, and subsequent refinement leads to design representations at much lower level of abstraction. Now let us move on to something called as what are software attributes and what are software qualities. You can say these are sort of design principles. Throughout the design process, the quality of the evolving design is assessed with a series of technical reviews. The three characteristics serves as a guide for evaluation of a good design are: the first characteristic is design must implement all the explicit requirements contained in the requirement model, and it should also accommodate all implicit requirements desired by the stakeholder. The design second is the design must be reachable, it should be understandable, and it should help to generate code and test cases. The third one says that Design should provide a complete picture of the software, addressing the data, functional, and behavioral domains from implementation perspective. Now, each of these characteristics is actually a goal of the design process, but how are you going to achieve them? You can achieve them through quality guidelines and quality attributes. Let us move on to quality guidelines first. So, a design should exhibit an architecture that has been created using recognizable patterns. It should be composed of components that exhibit good design characteristics, and it can be implemented in an evolutionary fashion. Now, a design should be modular. Okay, it should contain distinct representations of data in form of architecture, interfaces, components, and class or data. It should lead to data structures that are appropriate for the class to be implemented and are drawn from recognizable data patterns. A design should lead to component that exhibits independent functional characteristics. A design should create interfaces that reduce the complexity of connections between components and with external environment. A design should be derived using repeatable method that is driven by information obtained during software requirement analysis. And a design should be represented using a notation that effectively communicates the meaning. Lastly, we shall conclude with quality attributes. Functionality is assessed by evaluating the feature set and capability of the program, generality of the functions that are delivered, and security of the overall system. Usability is assessed by considering human factors like overall aesthetics, environment, consistency, and documentation. The reliability is evaluated by measuring the frequency and severity of failure, the accuracy of output results, mean time to failure, the ability to recover from failure, and the predictability of the program. Performance is measured by considering processing speed, response time, resource consumption, throughput, and efficiency. And lastly, supportability combines the ability to extend the program using extensibility, adaptability, serviceability, and all these three attributes together represent a common term that is called maintainability in addition to testability, compatibility, configurability. Okay, so with this, we are concluding our today's session. We shall meet up in the next. Thank you.